Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. Okay, look at this question. We have 1000 kilogram sports car accelerates from 0 to 25 meter per second in 7.5 seconds. What is the average power delivered by the automobile engine? So we need to list out the information first, where we have M, U, V, and T, which is equals to 7.5 second. So the question asks to find average power. Do you still remember what is the formula for average power? It is equals to W work done over delta T. Okay, so for this case, we can use work done equal to the delta KE. Okay, by using the conservation of energy, work done is equals to delta KE, since we have the initial and final velocity of the car. Okay, let's substitute the value of the information. So P equals to half M 1000, V 25, U 0, and delta T 7.5. So by substituting all the information, we get average power equals to 4.17 times 10 power of 4 watt. Alright, let's move to the next question. When a particle moves in a horizontal circle with angular velocity omega 1, the centripetal force is F. When it moves in the same circle with angular velocity omega 2, the centripetal force is 2F. What is the value of omega 1 over omega 2? So we have particle 1 moving with omega 1 with the Fc equals to F. And for the second particle, it is moved at the same circle and have 2F Fc with omega 2. The question is, what is omega 1 over omega 2? So we list out the information. Omega 1 with F, omega 2 with 2F. So what is the relationship between omega and F? So we know that Fc is equals to mv squared over r and equals to mr omega squared. And when we rearrange the equation, r will be equals to Fc over m omega squared. Okay, we equate r1 equals to r2 and substitute the information. Okay, we can cancel the m and f. We get omega 1 over omega 2 equals to 1 over SITI, where it is equivalent to 0.71. So that for this question, the answer will be C, 0.7, the nearest to 0.71. Okay.
Okay, continue with question number 13. Okay, calculate the gravitational potential energy at 130 kilometers from the Earth's surface for a 75 kilogram object. Okay, so you are going to find gravitational potential energy here. which is the symbol is U. Okay, gravitational potential energy at 130 kilometers from the Earth surface. Okay, so untuk mengelakkan sebarang kesilapan, okay, it's better for you to visualize. Cuba lukis macam mana 130 kilometers from the Earth surface tu. Okay, so let's draw first. Okay, the Earth, and this is the object which is at distance of, okay, mana objek tadi, 130 kilometers here. Alright, so gravitational potential energy U, and the equation for gravitational potential energy, okay, by referring to your list of formula that will be given in your PSPM, boleh tengok dekat situ, boleh pilih mana equation yang sepatutnya awak guna, which is U is equal to negative G M capital M small m over R. Okay, in which G is the universal gravitational constant, okay, and M, capital M here is the mass of the Earth, and another small m here is the mass of the object lah dalam kes ni. Okay, and then divide by R. What is R? R is the distance from, okay, kat sini kena hati-hati sikit. Okay, R is distance from center of Earth, okay, to the object. Okay, so you have to find R dulu. Kira dulu kat luar R tu. Okay, okay, another information yang tak lengkap kat sini, radius and mass of Earth, okay, which is equal to 6.4 times 10 power of 6 meters and 5.98 times 10 power of 24 kilograms. Okay, yang ni akan diberi juga. Okay, dalam soalan ni dia tak termasukkan. Okay, so R will be equal to R, since R is measured from center of Earth, so you have to plus with radius of Earth with, okay, the distance here, distance from surface. So tambah kena tambahkan 130 kilometers. So radius of Earth is 6.4 times 10 to the power of 6, okay, plus 130 kilometer. Kilo is 10 power of 3. Okay, and then you will get your R will be equal to 6.53 times 10 to the power of 6 meters. Alright, so lepas tu barulah kita boleh substitute into this equation to find U. Okay, G, value of G also can be obtained from the list of constant that also will be given in your PSPM. Okay, G is 6.67 times 10 to the power of negative 11. Okay, capital M tadi mass of Earth, which is 5.98 times 10 to the power of 24 kilograms, and another M is mass of the object, which is equal to 75 kilogram. Okay, divide by R is 6.53 times 10 to the power of 6 meters. Okay, so the answer you will get negative 4.58 times 10 to the power of 9 joule, isn't it? Okay, ada negatif tau. Okay, in your DAQ question yang diberi sebelum ni, dalam pilihan jawapan tu semua tak ada negatif. Sorry tau, dia tertinggal. So kat sini saya dah betulkan. Okay, and from this answer, okay, yang paling dekat dengan jawapan kita ni adalah ni lah kan, negative 4.597 times 10 power of 9 joule. So the answer is D. Okay, next question. Question 14. Okay, a 3.5 times 10 power of 6 kilogram space shuttle orbits at an altitude of 250 kilometers above the Earth's surface. So how long does it take for the shuttle to complete one orbit around the Earth in hours? Okay, ni pun sama juga. Kena hati-hati kat sini. Ada space shuttle at a distance of 250 kilometers above the Earth's surface. So kita lukis dulu. Okay, Earth. And then ada space shuttle kat sini at a distance of 250 kilometers above the Earth's surface. So how long does it take for the shuttle to complete? Berapa lama? So kita nak cari berapa lama masa. So we are going to find T. For the shuttle to complete one orbit. Okay, masa untuk satu putaran lengkap also equal to period, isn't it? Okay, so here we will use the concept of period in satellite motion. Okay, so tengok dalam list of equation, period for satellite motion, the equation will be equal to T equal to 2 pi square root R cube over GM, isn't it? Which is R here also sama dengan yang tadi. R will be measured from center of Earth to the satellite. So kena kira dulu R tu. So R also will be, you have to plus with the radius of Earth dengan distance above the Earth's surface, which is 250 kilometers. Radius of Earth just now 6.4 times 10 power of 6. Okay, plus with 250 times 10 power of kilo is 10 power of 3. Okay, so you will get R will be equal to 6.65 times 10 power of 6 meters, isn't it? Okay, next we are going to substitute all values into this equation, into our equation. Okay, 2 pi square root R cube. Okay, the value of R just now 6.65 times 10 power of 6. Okay, divide by G. Okay, so G is also equal to universal gravitational constant, which is the value is 6.67 times 10 power of negative 11. And here capital M is mass of the Earth. Okay, jangan tersilap pilih mass kat sini. Capital M is mass of a point mass in satellite motion, and our point mass here is the Earth. Okay, bukannya mass of the space shuttle tadi. Okay, so mass of the Earth is 5.98 times 10 power of 24 kilograms. Okay, by substituting all these values, we will get the period will be equal to 5395.09 second, isn't it? Okay, but here in unit second. Okay, cuba tengok balik dalam soalan ni, dia mention dia nak dalam unit hours. So you have to convert from second to hour. Macam mana nak tukar? Kalau daripada hour to second, hour 1 jam ada 60 minutes and 60 seconds, so we have to times, right? Tapi kat sini daripada kecil ke besar, so we have to divide lah, kan? So we have to divide with 60. 60 ni kepada 60 minit dulu, and then 60 second tukar minit. Okay, and then lagi kena tukar lagi, divide lagi by 60, another for 60 minit untuk jadikan satu jam. Okay, and then kita akan dapat 1.5 hours, kan? So the answer will be A.
Hi, now we will look at question number 15. So question number 15 is about simple harmonic motion. Okay, kita tengok soalan dia. Figure 3 below shows how the displacement x varies with time t for a system undergoing simple harmonic motion. Soalan ni dah cakap kan sini. Ni soalan simple harmonic motion. Okay, so kita ada graph x against t. So apa yang kita boleh dapat from the graph? So first kita extract dulu. So sini kita ada 0.3. So 0.3 ini, this is the value of a. So a kita 0.3 meter. Lagi boleh dapat apa lagi? X against t. So dekat sini, ni value. This is our t. So t equal to 0.4 second. Okay, so simple harmonic motion. So kita ada omega. Kita boleh dapat omega. Omega equal to 2 pi over t. So sini kita dapat 2 pi over 0.4. So meaning our omega equal to 5 pi radian per second. Okay, kita dah ada A, kita dah ada T dan kita dah ada omega. Soalan dia nak apa tu? So determine the displacement of the system when T is 2.5 second. So dia nak cari X when t is 2.5 second. So check position dia. So kita recall balik what is the general equation untuk simple harmonic motion. So kita ada x equal to, graph ini graph sin kan. So a sin omega t. So kita dah ada value of a. Kita masuk sini. A kita 0.3 sin kita punya omega is 5 pi t. Okay, so this is our equation. Then soalan tu dia nak find the displacement of the system when t is 2.5. Okay, so that when t is 2.5 second, equation kita sini kita just masukkan je t kita x 0.3 sin 5 pi time with 2.5. So make sure calculator in mode radian. So masukkan sini kita dapat. So sini kita dapat 0.3 meter. Okay, so meaning that the answer is C. Okay, that one for question number 5. Kita tengok pula question number 16. So question number 16 ni, soalan ni sama graph dengan tadi So kita dapat sini from the graph kita boleh dapat value untuk A. So this is graph X against T kan. So kita dapat A dia dekat sini. So unit is meter. A equal to 0.3 meter. So T dia, so dekat sini, T is 0.4 second. So from T we can get omega. Omega equal to 2 pi over T. So sini kita dapat 2 pi over 0.4 sini. So here is 5 pi radian per second. Okay, soalan dia nak equation of displacement as function of time. Dia nak equation. So kita keluarkan dulu the general equation for simple harmonic motion. So x equal to a sin omega t. A kita 0.3 sin 5 pi t. Okay, ada tak jawapan kita? 5 pi tak ada. So kita kena tukar, cuba tukar ini. So 5 pi itu sebenarnya sama juga dengan calculator. So here is 0.3 sin 15.71t, and the answer is B. Okay, so settle for question number 15 and 16. Thank you.
Okay, now we will discuss question number 17. Okay, a pendulum box of 200 grams is attached to a string of 1.2 meter length that undergoes simple harmonic motion. Determine the time taken for the pendulum to oscillate one complete cycle. Okay, so it is simple. First of all, you need to list out all the information given. Okay, so right now you have the mass for the pendulum bob. It is 200 grams. And you need to change into kilogram, into SI unit. So become 0.2 kg. Okay, 0.2 kilogram. And the length for the pendulum is given by 1.2 meters. Okay, and the objective of the question is you need to determine the time taken for one complete cycle. So as we know, time taken for one complete cycle we call as period. Okay, so the period, the symbol is capital T. Okay, and you also can sketch the diagram. Okay, just a simple diagram. This is your pendulum. Okay, and this is our length of the string. Okay, so it is straightforward question because you need to find the period. Okay, the period of the pendulum. Okay, so the equation is T equals to 2 pi times with the set of length over gravitational acceleration. Okay, then just substitute all the values. Okay, so 2 pi times with the set of 1.2 meters, and your G, it is a standard value. Okay, the constant value 9.81 meter per second square. Okay, so just use your scientific calculator. Okay, so then you can get the answer is 2.20 seconds. Okay, so the answer is C. Okay, simple, right? Okay, now look at to question 18. Okay, question number 18. And it is stated as an object with mass of 500 grams is hung vertically to a spring and cause it to elongate 0.55 meters from equilibrium position, and we need to determine the acceleration of the object if it is experiences simple harmonic motion. Okay, so as usual, take out your information given. Okay, you have the mass of the pendulum. Okay, 500 grams, and you need to change into kilogram into our SI unit, so become 0.5 kg. And you have the extension. Okay, the extension because it is elongate about 0.55 meters from equilibrium. Okay, 0.55 meters from equilibrium position. So it means your X, okay, or your E. it is the same lah. Okay, you can use the symbol of X or E. So your elongation is 0.55 meters. Okay, that's it. And you need to find the acceleration of the pendulum. Okay, and you also can sketch that diagram. Okay, so this is your object. Okay, and let's say this is our equilibrium point. So this point is when your X equal to 0. And this is X equals to 0.55 meters. It is in negative sign lah. And the other one is upper side. X equals to positive 0.55 meters. Okay, like this. That's our diagram. And how to find the acceleration? Okay, how to find the acceleration? Okay, as we know, because it is using the spring, okay, the equation for acceleration, it is A equals to negative omega square x, or you can use it as, okay, this is the standard one, but we don't have the value of omega or angular frequency. We don't have it. Okay, so we can use this type of concept, which is your restoring force, okay, is equals to applied force. Okay, so restoring force, it is equal to Kx, and this is equals to ma, right? So therefore, if you need to find your acceleration, so acceleration is equals to Kx over with the mass. Okay, now we check all the parameter. Okay, we have the mass, right? Okay, you have the mass. Okay, you have the mass, you have the x, but you don't have the k. Okay, you don't have the k. So you need to find k first. Okay, so how to find the k? Okay, how to find the k? Okay, so to find the k, based on the equation, it is state as. Okay, it is state as, once your object hung vertically to a spring, it is cause the elongation, means it is in equilibrium. Okay, in equilibrium. So the total force that acted on the object, okay, is equals to 0. Why 0? Once it is in equilibrium, okay, it is like this. You will have the weight and also the restoring force, right? Okay, so that's the basic concept from chapter 4. Okay, so now your restoring force minus with the weight is equal to 0. Okay, therefore kita change. Okay, we just change the equation. It is Kx equals to mg. Now you can find the k. Okay, so k is equals to mg over with dx. Alright, so m is, the value for m, 0.5 kilograms, and your gravitational acceleration is 9.81 over with your extension 0.55 meters. Okay, then you can find it, 0.5 times with 9.81 over 0.55. Okay, then you can have as 8.92 Newton per meter. So that's the value of your k. Now you can substitute into the equation of acceleration. Okay, the value of force constant is 8.92, and the K, and note the K, the X is 0.55, and the mass is 0.5 kilograms. Okay. Okay, so then you can get the answer 9.812 meter per second square. Okay, so this is the longest method lah, and the answer is A, apple. Okay, so the answer is A. Or the other method, not other method lah, you can substitute, you can combine the both equation. Okay, acceleration is equal to your K is mg over x, right? Okay, times with x over with the mass. Okay, so you can cancel the x and also mass. Okay, therefore, straightforward, you can have that acceleration is equal to your gravitational acceleration, and the value is 9.81 meter per second square. It is special for this question, eh? Okay, settle. Thank you.
Okay, now it's a turn for question number 19. Okay, the average sound intensity inside the busy restaurant is given by 3.2 times 10 negative 5 watt per meter square. How much energy goes to each here, okay, which is the given the area is 2.1 times 10 negative 3 meter squared during 1 hour meal. So, firstly, we list down the information given. So, the given the sound intensity, okay, I, okay, and then the value is given by 3.2 times 10 power negative 5 watt per meter square. Okay, and then it's given the area 2.1 times 10 negative 3 meter square, and the time is given by 1 hour. So we convert to seconds, so we will get 3600 seconds. And then the question asks you how much energy, right? And what is the formula involved? So we will use the sound density equation. So okay, or formula, I is equal to power over area, and the power is equal to energy over time and over area. Okay, so we will arrange back our equation. So how to get energy from these equations or formula? So E is equal to the sound intensity times with the area times with time. So we substitute the value here, 3.2 times 10 negative 5, and the area is 2.1 times 10 negative 3, and the time is 3600 seconds. So we will get the answer is about 2.419 times 10 negative 4. The unit for energy is joule. Okay, let's we see the option, the answer option A, B, C, D. And the answer is tada, A. Okay, 2.42 times 10 negative 4 joule. Okay, now we look at the next question, number 20. Okay, a triangle based on the stout string is modeled with the wave functions yxt equal to 0.2 sine 6.28x minus 1.57t. Okay, where x is in meter and t in second. Find the wavelength and period of the wave. So, we write down the general equation for the wave. Okay, so yxt is equal to a sine omega t plus minus kx, right? And the question asks you about find the wavelength and period. So what is the relationships wavelength and period in this general equation? So how to get wavelength? So we will use the
value of k wave function, and the formula is equal to 2 pi over lambda. Lambda is the wavelength, right? Okay, and how to get lambda? Lambda is equal to 2 pi over k. So let's we substitute the value. Okay, 2 pi over dengan 6.28. So we get 1. Okay, and the unit for lambda is meter. Okay, so the value for lambda here we will get 1 meter. Okay, and then how to get period? We will use the omega here. Yeah. Okay, omega is equal to, okay, the formula for omega is 2 pi over t, and the question asks you the period. So t is a period, is equal to 2 pi over omega, right? Okay, and then we substitute the value omega from the equation. So omega is equal to 1.57. So we get 2 pi over 1.57, we will get, okay, 4. And then the unit for period is second. Okay, so the lambda we will get 1.0 meter, and the period is a 4.0 second. So the options, the answer option is, okay, A, B, C, D. So lambda is a 1 meter. Okay, and the period is 4 second. Okay, sorry, this is a second. Okay, so the answer is D for number 20. So the answer is D. Okay, ta-da. Okay, now we will continue with the next questions.